All right, so yesterday we started talking about solving inequalities, and we're going to be writing all of our answers for these inequalities using interval notation. So on this first inequality, part D, where would you recommend we start here? We want to isolate x, we want to solve for x. Where would be a good starting place? Yes, let's multiply by 5 on all sides so that we can clear out that fraction. So I'm going to multiply each piece here by 5. That's going to cancel with my denominator in the middle so that I have 15 is less than or equal to 2x minus 9 is less than 35. And what seems like a good idea next? Add 9 to all the sides. (15 plus 9 gives me 24. Less than or equal to 2x. Less than or equal to 35 plus 9 is 44. And to finish this off, divide everybody by 2. Oh, I accidentally stuck in an or equal to down here, and I should not have. Sorry, my apologies. I got overexcited with my little or equal to signs. All right, so I have 12 is less than or equal to x, which is strictly less than 22. So I have my inequality notation here for my solution set. What would my interval look like? Yes, sir.
Bracket 12, comma 22.
Yes, bracket 12, comma 22, parentheses. What would this look like if I had asked you to graph the solution set?
Shape dot 12 or an open dot 22.
Yes, 12 and 22. You said a closed dot on 12. There we go. Closed dot at 12, open dot at 22, shaded in between. Beautiful. Where would you start on part E? I can think of a couple places that we could start. Where do you want to start? Subtract 4 from all sides. So minus 4, minus 4, minus 4. So I have negative 4 is less than negative 1/3 x, which is less than negative 2. Yes, sir. Multiply all the sides by negative 3. That's going to flip our signs, absolutely. So even if I don't do anything with the signs right away, I do want to show why our signs are flipping, because sometimes there's some confusion about that. Before we multiplied everything through by negative 3, you guys agree that negative 4 is less than or left of negative 2 on the number line, right? Once I multiply by a negative, is it still true that what I have written to the far left over here is the smallest value? No. If I don't flip my inequalities, this makes no sense. I'm saying that 6 is bigger than 12, and that's nonsense. So 12 is greater than x, which is greater than 6. If I was asked to write my final answer as an inequality, I would not want to write it like this, because even though I flip my signs, when we write a final answer in inequality notation, you always want the smallest thing on the left and the largest piece on the right. Yes, 6 is less than x is less than 12 would be my inequality solution. Good morning. Thank you, Mary. Good morning. Oh, as I run into things. So what is my interval solution here? Yes, parentheses 6, comma 12. first step on part F. What would you need to do to begin this problem? Distribute. I want you guys to go ahead and do that on your papers. Distribute both sides of the inequality on part F. I'll give you a minute or so to do that. All right, so distributing the left-hand side. I'm going to end up with 8x squared minus 2x minus 15. Is that correct once you get all your like terms collected? Mm-hmm. Okay. Bring down my inequality here, and we need to double distribute over here as well. And so I end up with 8x squared minus 55x, okay, minus 7. Everybody good with that so far? Even though this is quadratic, I like what just happened. What am I going to get to do? I'm going to be able to subtract 8x squared from both sides, and then this is no longer quadratic. So that part's going to cancel out. So after we get rid of those pieces, what should we do? You can either add 2x to both sides, or you can add 55x to both sides. I like adding 55 because that makes it positive over on the left. So I'm going to have 53x minus 15 is less than or equal to negative 7. Add 15 to both sides. 53x equals 8. Not equals, sorry. Less than or equal to. 53x is less than or equal to 8. Divide both sides by 53. Is this going to be able to reduce at all? Nope. X is less than or equal to 8 over 53. So my inequality notation, my interval notation for this solution would be what? Yes, negative infinity has to have a parenthesis there because we can't ever arrive at infinity, to 8 over 53, but we get a bracket here. This would be closed right there and open on the other side. Do you guys have any questions for me about these three? I want to look at some rational inequalities. I just want to start off with, what is this inequality right here asking me about? Yes. This is saying, when is this fraction negative? How do we get negative fractions? Yeah. So A over B, sorry, that looks like a 9. A over B is negative when A or B, but not both, are negative. What would happen if both numerator and denominator were negative? Yeah, we'd end up with a negative divided by a negative, and we'd end up with a positive value, so that's just going to cancel out there. Is there any way that that numerator can be a negative number?
No.
No, that numerator is a constant. So 4 is a positive constant. So if this fraction is negative, where is that negative happening at? The denominator. So the denominator must be negative. All right, so I've got a whole bunch of writing up here and not a whole bunch of math, but I think we finally know where to go to solve this one now, right? All right, so I'm going to take just what's on the denominator, 3x minus 5. What would be true about that value if it was negative? I want to be able to write this rather than just say 3x minus 5 is negative. How can I say that symbolically?
Less than 0.
There we go. Is less than 0. If it's less than 0, by definition, it would then have to be negative. And then I'm going to solve this. So I'm going to add 5 to both sides. 3x is less than 5. Divide both sides by 3. So x is less than 5/3. As long as we choose a value that is smaller than 5/3, that should make this entire fraction a negative, correct?
Correct.
Could we test that to find out?
Yes.
What could we do to test it?
Substitute 5/3 for x.
I don't want to substitute 5/3 in for x. What would be the problem if I put 5/3 in? It's not or equal to, but what's the bigger problem? I'm going to get a 0 in my denominator. I can't get a 0 in my denominator. That's against the rules of all fractions ever. But I could choose a number that is smaller than 5/3, like 1, right? I could put 1 in the place of x to test this. What happens if I put 1 in here?
4 over -2.
4 over -2. That's going to give me a negative. I can test the other side of it by choosing something that's bigger than 5/3 and verifying that I get a positive value then. So something like, I don't know, 3. That would give me 9 minus 5, 4 over 4. I get a positive value. So anything smaller than 5/3 is going to give me a negative fraction there. Anything larger than 5/3 is going to give me a positive fraction. And it can't be right at 5/3 again. Why? Because the denominator can't be 0. That's actually something that we're going to need to watch out for on any of these fractions, because even if it has this or equal to with it, can I have a value that would make my denominator a 0? No. All right, let's finish off part G. What's my interval notation here? Negative infinity, comma 5/3, parenthesis. I want you guys to try part H on your own. Very similar, except this time I want to know where it is greater than or equal to 0 instead of less than. Give this one a try, see what you can do. So tell me how you approach this problem. What do we need to do as our first step? Yes, Hayden. Yes. So as my first step, like on my own paper, to write notes to myself so I know how to approach these problems moving forward, say 2 is always positive. So for the fraction to be positive, for the fraction to be greater than or equal to 0, the denominator must also be positive. So that's kind of what I'm thinking in the back of my head as I approach this problem. So I know that x minus 7 has to be greater than or equal to 0, which means that x is what? X is greater than or equal to 7. Can it actually be equal to 7? No. Because that would make my denominator 0. So my actual solution is not that x is greater than or equal to 7. My actual solution is just what? Yeah. X would have to be strictly greater than 7. If it's anything less than 7, I'm going to get a negative on the bottom, and that doesn't satisfy what they asked me at the beginning. If it's equal to 7, it is undefined. If it is greater than 7, then my fraction can be greater than or equal to 0. So interval notation. Bracket or parenthesis? Parenthesis. 7 comma infinity. If you have always relied with interval notation on going, well, there's a greater than or equal to, it's got a bracket, please be careful if you have a rational expression, because we can't have our denominators equal to 0. So far, so good? All right. Absolute value. Ugh. 2 solutions, yes. What is part I actually saying? Like, if you had to interpret this for somebody that's never seen this before. Yes, Eni.
Sorry. It's saying the distance from x to 0 is less than 0. Than 3.
Yes. The distance, and you're correct, from x to 0. The distance from 0 is less than 3 units. So if my distance is less than, am I very, very close to 0 or very, very far away from it? Very close. I have to be less than 3 units away from 0. So I'm going to think about this on a number line first. What are my boundaries then?
Negative 3 and 3.
-3 and 3. Where would this be shaded? In the middle of those two. So we would have open intervals here, open sides, open circles. In between. Right, so as an inequality notation, anywhere I shade are values that are valid for x. So -3 on this side, +3 on this side. X is somewhere in between those two values. Whenever I have an absolute value inequality, once I have my absolute value isolated like I did here, I'm going to have the positive on the right and the negative on the left for a less than absolute value. If my distance is less than, then I'm going to have a compound inequality like this. So I would have as a solution set -3 to +3, parentheses around those. For part J, we've got another less than. So I'm using this same idea, this same metric. I'm going to write something that looks a lot like this guy right here, except what's inside my absolute value is what's going to go in between those two inequalities. So this right here is what has a distance less than 4. So 2x plus 5 goes in the middle. What is my lower boundary here? -4 would be my lower boundary, to be 4 units away on the left. My upper boundary is going to be +4. And now I solve this like some of the earlier problems. Go ahead and finish that one out for me. All right. What'd What'd you guys get? Negative 9 halves and negative 1 half. Subtract 5 from all sides. Negative 9 is less than 2x is less than negative 1. Divide everybody by 2. Negative 9 halves is less than x is less than negative 1 half. So parentheses, negative 9 halves, comma, negative 1 half. Beautiful. You guys are rocking this. I got 2 more problems and we're done with this section. Let's look at these guys. All right, I need my distance to be greater than or equal to 2 units from 0. So I just want to think about this for a second off to the side. If I have a distance that is greater than or equal to 2 units from 0, I know negative 2 and positive 2 are going to be important pieces here, but they're not necessarily boundaries. Yes, sir? Yeah, they're going to be going opposite directions. So negative 2 or farther this direction. Positive 2 or farther this direction. So instead of writing one compound inequality where I'm shaded in between, so what's inside my absolute value goes in between these two, I have to write 2 separate inequalities, one for each tail here, one for each side. If I have it shaded off to the left, is that a greater than or a less than? Less than. All right, so I have 2 minus 3x over 5 is less than or equal to negative 2. Because if I am 2 units or more away to the left, as I'm going off to the left, that's a less than. Or the other possibility is that 2 minus 3x over 5 is what? Greater than or equal to 2, yes. So we're going to have to solve the 2 of these together. Since we've got that gap in the middle, we're going to end up with a solution set that has a union. We're going to write 2 distinct intervals with a union between them, telling me that there's space in the middle that's not shaded. So I'm going to multiply both sides by 5. So I have 2 minus 3x is less than or equal to negative 10. Subtract 2 from both sides. So I have negative 3x is less than or equal to negative 12. Divide both sides by negative 3, and please be careful here. Sign x is greater than or equal to 4. Still need to solve for the other side. I cancel my 5's out, so I have 2 minus 3x is greater than or equal to 10. Subtract 2 from both sides. Negative 3x is greater than or equal to 8. Divide both sides by negative 3. I'm going to have to flip my sign again. X is less than or equal to negative 8/3. Which one of those is describing the left-hand side, the lower portion of my solution set? This guy right here is describing the left-hand portion, because that is x is less than some value. This one should go to describe my right-hand side. So before I write my intervals, I like to get these turned around so that my intervals actually make sense with a number line. I would never want to write 4 to infinity union and then write something that is smaller than that. Infinity should always be the last thing that you write. If you have infinity in any of your intervals, that should be the last portion. What would my interval be for x is less than or equal to negative 8/3?
Negative infinity, comma, negative 8/3 bracket.
Yes. Negative infinity, comma, negative 8/3 with a bracket. My or here is a union. When you guys type that into the computer, you're going to use just a capital letter U for your unions there. And then I'm going to need a bracket for the 4 off to infinity. If there's a union involved, you should never, ever, ever see a negative infinity come in the second part. If there's a negative infinity, that should always be the first thing that you write down, because that is by far farthest to the left. Same thing with infinity. If there's an infinity involved, it would always be farthest to the right. All right. One last problem, and we're going to call this done. How should I go about solving this? The 3 is a constant. It will always be positive.
It could also be positive. It doesn't say it has to be negative.
It says it has to be less than 2. If it was a 0 over there, absolutely. I'm all over this, because 0 is my dividing line between positives and negatives. And I can find places where it's 0 and go, okay, on this side it'd be negative, on this side it'd be positive. I need to isolate that absolute value. If I could get that absolute value isolated, like in part K, then I can set it up and solve it similarly to part K. How do I get something out of a denominator?
Multiply by it.
Multiply by it. So I'm going to multiply both sides by this denominator. I do not want to distribute this, though. 3 is less than 2 times the absolute value of 5 minus 2x.
Just immediately divide by 2.
Immediately divide by 2 after that. And now I've got my absolute value isolated. Is this an or where it'd be shaded off to either side? Or is this an and where my distance is less than and I'm running in between? How do you decide?
If the absolute value is greater than
Yes.
4.
Alligator always eats the bigger thing. It's saying this over here, an absolute value means distance, so my distance is greater than this. If it helps, write it down the other way. 5 minus 2x. Alligator still has to eat the bigger thing. So 3/2. And then you can see that this would be shaded in opposite directions. I want you guys to go ahead and finish this one, and then we'll compare answers. And that is going to finish off 2.6 for us. Hopefully you guys are winding down with this one. Dividing a fraction by another value is the same thing as multiplying by its reciprocal. So instead of dividing by -2, I could say I'm multiplying by -1/2. Don't forget, when we have those negatives, our inequalities flip around. So I would have that x is greater than 13/4, or
That 7/2 should be negative.
it will be now.
But if you did 3/2 minus 5, would it be negative 7/2?
Yes, you are correct. So now it's going to turn positive. You're right. I wasn't looking high enough on my own notes. X is less than 7/4. I like to rearrange these before I write my interval, if necessary. Would the negative infinity, with the way I have it written now, if I just wrote down my intervals underneath these, would I have the negative infinity first? No. So I'm going to rearrange these so that my interval notation right underneath it matches with what I'm seeing. X is less than 7/4 or x is greater than 13/4. So my intervals are what? Negative infinity to 7/4, parenthesis, big U, parenthesis 13/4 to infinity. That would be my answer using interval notation. Beautiful work today, guys. I am going to pass back, not the quizzes from yesterday, but the one before that, the one with the story problem that you did in partners. I'm going to go ahead and pass that back. You guys already have your review for the test, correct?
Yes.
Okay, and I need to get you yours.
Do you grade reviews?
I do not.